All right. Can we all see my question? Hello, colleagues.
Sure.
Can we all see
I'll
it?
be back now. I just need to look at something.
Okay, no problem. Can I move on? Is it Lori, I think?
Yes, you can.
Ashwin? Okay.
Yes, sir.
Luvuyo? Okay, cool. So like I said, we're going to be doing integration area under curves. I'm not sure what paper this is. I'm going to just check again, but I saw a student posted this particular question in a group. Therefore, I decided to, okay, let's tackle this one. Let's quickly read. It says, sketch the graph of x equals y squared, right? And clearly indicate the area between that graph and the x-axis, and then x equals 0 and y equals 2. Okay. Second following question is obviously calculate the magnitude of the indicated area in question 5.31 with the aid of integration. All right. So let's begin with sketching our first graph. Now, if you already know your parabola standard y equals x squared, you should know that that should be like that, right? That's your standard. But obviously in this case, it's kind of flipped around, and now we have y equals y squared. So in this case, it's not going to be that way. It will most likely be something like this. Okay. And if you're uncertain on how you want to actually plot the graph, the best thing you would have done is just open up a table of x squared, y squared. We'll start on maybe, let's say we start on 0, 1, 2, and 3, right? And then you substitute these values into the equation of x equals y squared. So it's back to some of the functions. Obviously, this would be 0. This guy would be 1. The next one would be 4, right? This one would be 9. Maybe we can add another one, and that would be 16. So then, if you plot the graph, right? Let's use this here quickly. I can use grid line. Okay, it's fine. So you have a line like that. It's rotating, and another line like that. And then, based off your values, let's quickly look again what it was. Let's make this big. Our first point is obviously there. Our second point is 0. It's 1 and 1. I hope you guys are with me, eh? Are you guys with me? The
Yes,
next
sir.
point is, what is it? 2 and 4. Okay, let's say it's over here. I believe you guys are with me here. No? I'm just obviously creating fictitious type points. So this is going to be 0, 1, 2. This will be 2, 4. Obviously, what I should have done is started from the negative side as well. You know what I mean? That would have actually helped. Didn't make a big difference for this question, but maybe you're always going to choose a range from -3 till 3 or -5 till 5. Then, long story short, you should get a graph going like that. And the way now it's a parabola on the virtue that it's squared. And obviously it's going to go like that. Assuming you put the other x values in, like -3, -4, and it should obviously give you these values over here as well. Okay. I hope that's clear to everyone. And then, let's say interior indicate the area between this and the x-axis, right? So the x-axis is obviously this. X equals 0, okay? X equals 0 is over here, and y equals 2. So if I remember rightly, y equals 2, if you have x equals 2, it'll just be a straight line going like this, right? That's what that is. So if y equals 2, the line will just go like that. So therefore, if I zoom into this guy quickly for you, I'm gonna zoom in. Just go zoom. Zoom in. Thus, that area. See this piece over here? I probably should shade it in. Can you guys see it? See that area over here? This piece over here? That's the area in question they're talking about. Right? And the x-axis, x equals 0, y equals 2. Is there any questions thus far? So everyone seems a bit quiet, or because it's Friday.
Just following along, sir.
Okay, okay. So if you're unsure, you can.
Day.
It's been a long day, yeah? Of course, it's Friday. So that's what we're gonna do there. And then yeah, so that's the first part, right? And then they say the next part is calculate the magnitude of the area indicated in the following question. So we need to find what is this area. So now let me just quickly remind you on how this works. The area is going to be equal to some function minus some function dx, right? But what is key to remember, obviously there's going to be an upper limit, I think it's called b, and a lower limit, if you remember. Now, in this case, we are looking for, there's two ways to do this question, actually, just by the way. We could say f of x minus f of x, or the other alternative is we can say x2 minus x1, right? Meaning the top function always, remember, always at the top minus the bottom. Or we can say area equals, is it going to be y2 minus y1, right? Something like that, dx. But the difference is if you are using in the x direction, you gotta use the bounds of the other side. So you're integrating from 0 to 2. So that's what's important over here. So let me rather put it like this. Let's say it's going to be y2 and y1, like that. And if you're using the y, that's going to have to be now x2 and then x1. Because what you're doing is actually calculating these strips here, and your integration obviously need to explain to you properly. It's a sum of all these individual elements. Those pieces here are called the dx. So we're actually adding up each individual one. So let's quickly try this one here. So if I say areas here, and normally your bounds, by the way, like I mentioned to you before, are your points of intersection, right? So if you look at this would be 0 and 0. And the other one would be obviously, what point would this be here? Does anyone know? Obviously, my graph's not to scale, but how do we find the next point of intersection? Does anyone know? Does anyone know? Ashwin, Dalmari, Kanisa, Lyndon, Vuyo, Lori. The points of intersection, guys, again, it's always quite simple. You're going to make the two graphs equal to each other. I hope you guys can recall that, right? So in this case, this is our two graphs, our two functions. And then we just make them equal to each other. But this is fairly easy because one's already in terms of the other one. So we substitute 1 into 2. Okay? I'm sure you guys know this, to make f of x equal to g of x, whatever you want to call it. The one function equal to the other one. And then, so this will be x equals, putting that in, 2. And we know x will be equal to 4, right? So you know your first point is going to be, yeah, so that's fine. So we substitute that, so we know our x coordinate for the 1 point is 4, okay? So 4 will be over here somewhere. I don't know if my graph is actually right here, you know. So it should have been 4. There should have been 4 over here at this particular point here. The scale is obviously not right. Just remove that. Perfect. And then once we have the x coordinate, obviously we need to get the y. And what of my y in this case was 2 and 4. So it's 4 and 2, right? So 4 and 2. So x is 4 and y is 2. That's where that actual point is over here. I hope that's clear to everyone. So that should have been 4 at that particular section. Yeah. Okay, so once that is done, we have to look at our points of integration now. So looking at this, we're integrating, as I said, it's from the x-axis. So we're not integrating like this. We're not integrating the y. So you know what I mean? We are integrating this piece, and so therefore our bounds from this area. In fact, the strip is not like that. The strip I think the strip would obviously be like this now, because we're integrating this way up. So it should go up from 0 to 2. So our bounds would be 0 to 2. Okay. X2 will be the top one. But the top one in this case, the top graph is y equals 2, and there's no x value. So that should actually be just 0. And then we're going to have minus. And then let me just check here, a top graph minus bottom graph, and then our bottom graph should be y squared. Wouldn't make much difference in this case over here. And then we obviously have to integrate all of this now. Now I'm just checking now. If I look at my graph from that perspective, so it's x2 minus x1. You know, if you look at it from the other way, this should be on top of that one if you're integrating that way. So I would have said probably that one minus that one. But anyway, the magnitude would be the same. This could have been flipped around, because if you're working on the y-axis, you know, if this is your base, this is the top minus the bottom from there. But anyway, you'll do x1 after this. So let's assume it's like this. That's fine. I'm not going to stress too much about that. The magnitude should still be the same. We're left with a definite integral from 0 to 2 minus y squared. And then dx. This also is worrying me, this dx, because it should not be dx. It should be dy. But anyway, okay. Because you're working on the change of y, not the change in x. So anyway. I don't think this, I'm looking at this question and I'm thinking, is it actually in the N5 or the N4? But nevertheless, this is dy. It must be dy, not dx. So trusting my mathematical judgment, I'll make this dy. It doesn't make sense for it to be dx. Nevertheless, you integrate, you're gonna have y cubed over that. You're gonna have that's your integrated function. I believe all can do that. And then our bound is obviously going to be 2 and 0. And then we're going to say x2 minus x1, if you guys remember. So we got to substitute. The first one will be 0. So this will be negative 0. Oh, is it I minus a lower a? I'm not going to get that right. Minus 2 cubed divided by 3. And then obviously the other one will be 0. So then we substitute negative y. Oh, this is going to be 0 over here. 0 divided by 3, that's squared. And let's quickly see, it should be 8 over 3. Okay, I get a negative 8 over 3, which does seem a bit It's incorrect because it illuminates negative areas. I could have probably did it on this side here, but nevertheless, I guess the magnitude is still right over here. Okay, so that's, once you have your answers, it's that squared. Yeah, you can just take the positive value of this. But I'm pretty sure that's dy. Now, if I were to do the other side here, right? And that's now, and this is now not integrating, but you'll be using now the x values instead, right? Let's quickly see if we can get the same answer. So our bounds in this case will be from 0 to 4, right? So if you're with me, those are my point of intersections, right? So 0 to 4 now, not 2. Hope you guys are with me. 0 to 4. So now I'm using the other side now. Then y2 would be the top graph. Now this is what I'm saying. This is on the x direction, this is on top, and that is at the bottom. In the y direction, this is actually, you see what I'm saying? I don't know if you guys are with me. In the y direction, if this should be y2 minus y1. So maybe that's where I can agree with that. That should have been y squared minus that. So I hope you guys are with me. And over here on the x side, it's 2, so that it's going to be fine. It's going to be 2 minus y1, and y1 obviously it's going to be, we have to work out what y1 is, because that's in x. So y1 should be x equals root y squared. We've got to put it in terms of y now. So that would be root x equals y. So therefore, this would be 2 minus root x dx. Okay, so yeah, so again, I think for sure, I'm confident now, looking at this, I'll make this x2 minus x1, and this will be y squared. This will be a positive. You can even make this, this is all positive. And I'll explain again why. Is that if you are integrating from the y-axis, right, you have to assume that this is like the base, and this will be on the top, that'll be at the bottom. So it's always top graph minus bottom graph, right? But if you're looking at the x perspective, which is now what we are comfortable with, so this is the x, this graph is on top, and obviously this graph is at the bottom. I hope you guys are with me. Yeah, I'm realizing now, but okay, anyway. So let's integrate this and see what we get. To integrate this guy, you should get 2x, if you guys remember integration, right? And your root x will be x to the power of plus 1, right? We add 1 here, so it's 3 over 2. And then obviously it's divided by 3 over 2, but you can flip this one, and then therefore it should be 2 over 3, like that. Okay. 2 over 3 at the bounds of 4 and 0. If I equal this, obviously I have to substitute. I'm not gonna, that's the first one, that's the second one. We know the second one will be 0. And hopefully this answer here will give us what's the answer I'm looking for. 8 over 3. I believe it might be right or might be wrong. Yeah. I should give you the same answer. If not, oh well. 2 times 4 minus 2 over 3. I'm just doing it on my phone here. And then x is 4, right? 4 to the power 3 over 2. Okay. And guess what you get? You get 8 over 3. I'll show you if you don't believe me. Just on the Casio. I'll share my calculator quickly. So I hope you guys are following what I'm doing. So I'm just going to show you that. Let me just say, we share screen, share screen. Okay, cool. So I'll open it up, and then here's my calculator. Can you guys see my screen? So I'm just going to show you 2 multiplied by 4 minus to power 3 over 2, 3 over 2 divided by 3, right?
3.
Yeah. Equal, no, am I missing something here? 2 times 4. Oh, okay, let me just do this again. That's 2 over 2 2 over
2
3,
to the
right?
power.
Yeah, exactly. So then it's going to be times 4. Sorry, it's got confusing. 3 over 2. Yeah, there we go. And you should get 8 over 3. Exactly the same answer, two different directions. And I'm pretty sure that's dy, not dx. Yeah. Let's just have a look at that memo. So there, that's two alternative ways. I hope you guys are following this one. I hope so. And again, yeah, that's probably positive. So this will be, if you're looking at the y, this will be the top and that'll be the bottom. And there's two ways to actually do it. Anyway, that's that one. Let's try the next one. Okay. I want you guys to try and sketch this graph before we begin. I'm just going to get the question quickly. Okay. Try to understand what you're doing, man. That's what's key. If you're unsure, make sure you get to the point of understanding. Okay, print screen. Okay, here we go. Another 5.3. And this is 11 marks. So I want you to try and do this one. So here we have y equals x squared plus a straight line. Again, and this one is easy. They're not talking about x-axis and all of that. And the reason why they're doing that is because there's two graphs. That's not because y is supposed to be normally on the, what is this? On the left-hand side. So you could think of this as an inverse of this particular graph here. But anyway, try and sketch that graph. Try to do number 6. Then, yeah, you can just check. Shouldn't take you that long to do. What's also important, calculate the point of intersection. Like I said, to calculate point of intersection, you make the one graph equal to the other graph. I hope that's clear to you. All right, I'll give you 3 minutes and then we'll move on. And guys, if you're unsure, please ask. All right, colleagues, are you guys done? You guys done?
Good evening, everybody. Sorry for being late. Yes, I'm just finished with it done now.
Okay. Oh, hi, Richard. Yes. Luvuyo, London, Lori. I'll paste the graph for you here.
Answer.
Yeah. I use the software. Draw that graph. I'll show you guys the software as well. Yeah. And that's what we're currently looking at, huh? Okay. What is my point of intersections? Can anyone tell me? Should be 2 points, right? Are we able to calculate it? Yes. What are 2 points? I'm waiting. So what I would have done, well, guys are still giving the answers. Like I said, you want to calculate points of intersection. You need to make the two graphs equal. So you say y1 equals y2. This will be x squared equals x plus 2. Or x perfectly, just carry everything over and get an old faithful trinomial. We're factorizing. That's a 2, that's a 1, that's an x, that's a x, that's a negative, that's a positive. So x will be equal to 2 and x is equal to negative 1. Exactly, you can see it over here, right? For us to get a corresponding y, if you want your y coordinates, all you must do is take these two values and put it back into either one of them, and you should get the corresponding y. But all we needed was the x, right? And the reason why is because we're integrating basically from here, 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 here. That strip there, by the way, is the dx. And again, if you look at the area integral sign, it's going to be f of x times dx. If I did articulate this is basically an area. So it's a function and a change in you're constantly adding, right? So the function obviously is whatever, and you're adding pieces. But anyway, so the next objective here is to determine the area bound by the two graphs, right? So it means where they intersect each other. So where they bound is basically from -1 till 2, right? And that there is our bound. So we always go the highest minus the lowest. And then for your function, like I said to you, and remember we are using we're on the x-axis. And so therefore it's going to be the top graph minus the bottom. And the top graph is the x plus 2. You guys agree with me? It's a straight line. Minus now the bottom graph, which is the x squared. And that'll be dx. Are we happy with that? Top minus bottom. Any questions around that? Can we proceed with the integration? Definite integral, right? Obviously, you want to differentiate each term. I believe you all have experience now. The x will be x squared over 2 plus a 2x minus x cubed over 3. And 2 and -1 must be substituted. Is everyone happy with that one?
Yes, sir.
Okay. So once that is done, we just got to substitute, right? So we substitute positive 2 to the power 2 divided by 2 plus 2, I'm substituting minus 2 cubed over 3. That will be my first value. Minus now, if you guys remember, you have to minus the second one. That's going to be -1 squared divided by 2 plus 2 -1 minus -1 cubed. Let me just bring that up here, make it bigger. Divide that by, just, here we go, divide that by, Erase again. So it's -2. I'm just substituting that in now. That's going to be negative. What is it again? -1 cubed divided by 3. All right. And then we must take that answer minus that and that. Can you guys give me that answer quickly? If you don't mind. I hope the protocol is clear here. I really hope so. If it's not clear, then we're not winning. Please, when you're done, give me the answer. I want you guys to find it on phone. Khalid, what is the answer? Let's move. Already 1:45 now.
$25 over 3, sir.
25 over.
Over 3.
Are you sure that's correct?
Yes, sir.
25 over 3. Khalid, what do you guys get? I believe my integration is correct. Yeah.
I get 26 over 3.
26 over 3. Aha. 26 over 3. Okay. Now, what I'm doing something on the calculator and I'm trying to figure out why I'm not getting what I need to get here. Okay. Anyone else?
I get 11 over 2, so
11 over 2. No.
yeah.
Yo, this
Because
what
for the
happens.
first one I got 10 over 3.
We're gonna check now, don't worry. I'm just checking something on my calculator quickly. -2 -1. What is the problem? So I'm getting a completely different answer. Anyway,
I think I might be wrong. Let me just redo it.
okay. Okay, let's do it again. I'm sure you guys can see my screen, right? You can see my calculator as well?
So
Yes, sir.
2, of course, the integration is definitely correct. I don't think we did anything wrong there. 2 to the power 2 divided by 2 plus 2 multiplied by 2 minus 2 to the power, so 3 divided by 3, right? So first guy is 10 over 3.
Okay, my mistake, sir.
Oh,
25 over 3, it's not correct.
yeah. This is the problem, you see.
Yes, sir.
No, it's cool. It's fine to make mistakes now. So the other one is -1, right? This is also -1. And other one is what? -1. So therefore we get -16. It is looking familiar to everyone. -13 over 6, like that. So it's
yes.
that minus that. Obviously we're gonna have to add them up now. Oh, okay. Let me just quickly add them up. Here's my calculator. That's gonna be 10 over 3 plus, right? Let's say plus 1 time. Is that okay?
Plus 13 over
13
6.
yeah. Which gives you 11 over 2.
So my answer was right.
So what did you get?
I got
2.
11 over 2, so
Okay, yeah. I see. You will just check what the memo gets. Memo could be wrong. That, and that's 11 over 2 units squared. I support this answer. Now what I was checking on my Casio here, said I wanted to verify this answer here, but I wasn't coming right. So here we can put in the function. You see,
How do you get that function, son?
you must have the VIP calculators, this one. I think Damari recently got it. I'm not sure if you have this one.
I'm still playing with mine.
Okay. New relationship, huh? Honeymoon phase.
Fresh.
So squared over here. Plus 2. There's a lot I can show you on this calculator. It's alpha x, then minus. The answers would come out exactly the same. This is what was worrying me. This is obviously x again, alpha x. Check if I'm typing the right thing. Sometimes it's hard to. And then we just put in our bounds. This is -1. Ooh, and the top is 2, right? So here we get 13 over 4, which is quite strange. Shouldn't be 13 over 4. Shouldn't be 13 over 4. Just want to see. I doubt this will change. The bounds must be higher than lower. So yeah, we should get exactly the same answer. But I'm not sure. I'm assuming this is all correct, 2 and -1, right? That should be intersected. Yeah, we should get the right answer here. I wonder what's going on here. Plus 2x minus x cubed. No idea. And I get 11 over 2 over here. Minus, yeah, okay. So I'm content with this answer. This answer should have been exactly the same. Not exactly sure how I get a different answer with this. Very, very, very strange. Okay, so any questions with this? So just key points. Obviously, sketching the graph, you should kind of know how to do that, right? Obviously, you want to take values maybe from -3 to 3 for each thing. Get the graph sketched to get 6 marks. You want to calculate the point of intersections, and the way we always do that is make the two graphs equal to each other. Obviously, we carry over everything to the other side. We factorize over here because we have a quadratic. Here are 2 points. And because we're dealing with the x direction, like I said, it's going to be this graph minus that one. For instance, if we're integrating through the y, and the bounds would have been from 0 to 2 in this case, it would have been this graph minus that graph, right? Obviously, the book doesn't show you the alternative ways. I'm just letting you know. And then obviously we integrate that function. It's a definite integral. Then we resubstitute that. What I would like to see is that we've gotten the same answer with the calculator, but I'm not exactly sure why. Okay, we all happy with this? Any questions? Any questions? Guys, please, the last, even if you don't have a question, squeeze out one. You know what I mean? There's no more questions after this. Better find one. I want to check something. I believe you guys can see the textbook here, eh?
Yes, sir.
Yeah.
Yes, sir.
Try,
Mm-hmm.
what you should try to do number 7 and number 8 this year. See these two? Do that tomorrow. And obviously you have the answer somewhere there. Right? Do these two. Is it clear to everyone?
Is the answers in the book right though?
I mean, you can do it and then just let me know, and I can obviously just check it for you. But if it's not right, and then yeah, just do it and just let me check. I'll check for you. Yeah. I mean, this was a sample copy, man. So yeah. Anyway, I'm not sure
I
they've got the
don't
final
like
one.
graphs.
What's wrong with graphs? What's bothering you?
Uh-uh.
No, what's bothering you? It's
I'm
not bad.
lost.
So where are you lost? No, talk.
Everywhere.
No, but where? So do you know how to sketch the graph?
If I don't have my points, I wouldn't know how to.
Okay.
For some reason, I go make y0 every time. Then
No, so again, if you don't have, you have two graphs, right? The best thing is for your first graph, y equals x squared. All you do is you take points, right? That's y, that's x squared. You take from -3, right? Oh, sorry. Oh, we need our input is over here, right? So from -3, what is it? -2, -1. So remember it's a function, right? F of x equals x squared. So you want to input values here. I don't know if that's clear to you. 1, 2, and then 3. So you input here, you get corresponding y values, right? Once you have that, you just plot each one on there. So if I do this on the Casio, I'll show you what I mean. If you're uncertain, you must say it, so we can show you. So it's really easy. It's really easy. It's a pattern. It was a mode table. F of x equals, what was it again? X squared, right?
x squared.
So alpha x squared equal g of x. We have a g of x, right? You can actually find the point of intersection now. Let me do it one now. So g of x is the second graph. So that's going to be alpha x plus 2. Are you guys with me? What I'm doing is there's two
Yes, sir.
different graphs. Yeah. Our start is our input value. So we're going to say we're inputting from -3 and we're going to end at 3. So what I'm saying is -3, -2, 1. Ask me the increments, step 1, which is exactly what I have here. I say equal. So what you currently have here is all the points for that. So we're inputting x and here we're getting f of x points. So this will be 9. Let me just go back here. That's 9. I don't think I can write 9, 4, right? And 1. This is f of x, right? And then we have, where am I now? 9, 4, and 1. Then it's 0, 1, and 4, and 9. Are you with me? You got that, no?
Yeah.
So what I mean here for this graph, our points are, what's my x? X is -3, y is 9. This one is -2 and 4. Are you with me? -1 and 1. Yeah, and then 0 and 0. 1 and 1, 2 and
2 and 4,
and
3
3 and 9.
2. Yeah, 3 and 9.
Yeah. So then you come over here. So then you say, where was -3? -3 was over here somewhere, argument's sake. And that's it's like around 9, right? So it's 9. So that's -9. That's a point there, right? That's that coordinate. Then we have -2, which is somewhere here. And that's at y is 4. I'm assuming you know the graph, the Cartesian plane works. -1 and 1. So that's -1 is here somewhere. That's simply somewhere over here. Okay. That's that point over there. Then we have 0 and 0. Is it not so? Then we have 1, 2, and 3. This is what a function is. So it's 1 and 1, right? 1 and 1 is here. Are you with me? 1 and 1, colleagues? What's the other one? 2 and 4,
Yes,
right?
yes.
Somewhere there. The other one is 3 and 9. Just like that. Then you take I'll take another color. So you must take another color and you just follow the points. You close it. And guess what you get? You get a parabola. Is that tough?
No.
Yeah, exactly. And then for this one, you do exactly the same, and your g of x is already done for you, right? So then your g of x will be a straight line. It'll basically follow a straight line path. So your first value will be -3, and you know what I mean, -1, -2 and 0, -1 and 1, 0 and 2. Are you with me? 1 and 3, 2 and 4. Now what you're going to find interesting for your points of intersection when you interpret these graphs, right? So if you scroll down here and you look, you'll notice what are the intersection points? -1, eh? You'll notice when they intersect, just check here. When they intersect, you find that they have the same value. That makes sense. At -1, you can see it's 1 and 1. You guys see that?
Mm.
Exactly, right? So that means they intersect at that point. If we've gone further, at 2, it intersects at 2 as well. Does it make sense? Obviously. It's at 4 and 4. It doesn't intersect again. So yeah, I don't know if that helped you.
I don't know if I'm the only one that's stuck with graphs.
Yeah, I must talk. So I'm just explaining. But was that clear
Yes,
in
sir.
terms of yeah? Just go over it again and then just see. It's really not tough, I promise you. It's not a lot of mind work. It's just like an application type of scenario. Is there any questions before I do the new section? The next section rather. Any questions, colleagues?
Good.
Okay,
Yeah.
okay. All right, so let me just quickly yeah, okay. Yeah, so I'm going back over differentiation here. Guys, so I'll be good at differentiation. Is there any questions I should tackle? I know what I want to do, but I'm just checking generally. Any questions? Your brain's tired today.
But yeah.
I think the stress is getting to
Okay.
us.
No, there's no
Yeah,
need for
that was well.
yeah, there's no
Okay,
stress, guys.
so for just from
Yeah.
so from my side is I think I'm okay with taking the integral or the differentiation.
Yes, yes.
But when it comes to simplify the answer, so say for instance a product rule, you need to take the different with the use of a product rule. Then you
Yeah.
take the obviously first times derivative to a second plus a second times
Yes.
derivative to first, and then you must simplify it. What order must it always be? Because it
Okay,
looked
no
like
worries.
I'm
Okay.
losing points there on once you simplify, because
Okay.
once you do the differentiation, that is the answer. But then always you
Yeah,
need to simplify it
no
as
worries.
best as possible. But now look like I'm losing a lot of points when that comes to the simplification.
Okay, no worries, no worries, no worries. Okay. So let's quickly go over differentiation. Now, obviously, there is a proper way to teach you differentiation, and I mean that I want to just I'm just finding something which I've done before here. Let me just quickly see. I'm not sure which. I was using ChatGPT to illustrate it. So I'm not sure which let me just go to yeah, I'm just gonna give you like a practical type thing, then I'm gonna go over the stuff. Just wanna see. Just wanna see if I can the key to understand, I mean, just on a philosophical point of view, is that you need to understand that what differentiation actually is it's the maths for continuous change. That's what it is. So anything where you're required to understand continuous change, it's let's say between two particular variables. This is what it's about. I think I have it open here, but I'm just want to confirm before I actually show it to you. Okay, I see it here. The application. I see it here. I'm not happy with what it's giving me. Okay, differentiation. I'm gonna have it there. Okay, I just want to see. Okay. Oh, I found it. Okay, cool. So let me just share my screen again. Then I will outline perspective, and then I will we'll do the product rule. So what I just prompted here was the application of product rule in differentiation. And if you remember what it is, what's key to note, this is all coming from your first principle formula. So you have two different functions, u of x, v of x, let's say a parabola in a straight line, times them together, and then you follow the product rule. Keep the first one, the second one, derivative of the first one, keep the first one, derivative of the second one. The order doesn't really matter. So that's the product rule, which I'm going to go over. And here's an illustration of what that is. So let's say, y equals x squared sine squared. You that u equals the first one, u of x, and the other one is v of, what's this? V of x. So the first x squared, find its derivative, it's 2x. Sine x is derivative is cos x. You apply the product rule, you keep that one, the derivative of the first one, plus the second, plus that, plus that. And obviously you can simplify this, but that's that. So I'm going to go over this again, but that's that. But what I wanted to show you over here is, this is what I'm talking about from the first principle formula. This is how they actually got. So this is like the godfather of differentiation. And it has all basically come from that limit formula, the first principles formula. And I explained to you over here how you basically get it. Okay. But what I want to show you was the following. So here's some application. I want to show you this one. So let's say in a mechanical setting, right? We want to look at the power transmitter. So I don't know if you guys know your power over time or power. So the functions of these are the two functions. It's torque with respect to time, assuming we measure torque. I don't know if you guys know how to measure torque. And obviously you can measure with a tachometer, your RPM, right? So let's say for a particular shaft, we are looking at some analysis. And obviously we know that the product of torque times omega will be the power. And what you can notice is there's a T, and that T is all over time. So obviously we're putting a monitoring device, we monitor the torque, we get the torque, and then we do the same with the speed over time. We have two different graphs. Remember, like I showed you the function, you have two different graphs. And now what we're going to do is those two, we curve fit the graphs, we get functions, and then we're going to apply this product rule. We apply the product rule on him. And the product will obviously be this over here. I think you guys are familiar with what I just mentioned to you before. Now, what's interesting about these things, the first term will tell you the change in power due to the increasing or decreasing of torque. So this will tell you the rate of what's happening to the torque, to the power with respect to torque. And the other one over here is the change in power due to angular acceleration. Obviously, because the derivative of omega, which is the speed, is acceleration. So then it says the total rate of power depends on two things. It depends on how the torque changes and how the speed changes. And here they give you like an example of this. So if your torque is increasing at 5 meters per second, your current angular velocity is at that much at the time, your current torque is that, and you can get to angular acceleration, you actually can get at that particular time. This means the shaft power output is increasing at 700 watts per second. So that's another way of, this is another way of viewing the product rule or using it. But anyway, let's quickly try to unpack the standard math within the stuff. So let's move along. So what I'm going to do, I'm going to start with product, quotient, and then I'm going to go to the changeable, right? Which people typically have a problem with. Just give this a second. So I'm just going to do, Richard, can you provide us with some does anyone some questions to do here? Let me just go back here and share this. Anyone have questions with us? Thing is frozen here. Close that. Okay, let's see. Just gonna go with the textbook and then see. Yeah. Now we do product and then quotient. Yeah. All right. Let me just try to do this again. I should be sharing now the book. All right. Can you guys see it? Yeah. Can you guys see it? Oh man. Page 50. All right. 50. 0 is in. There you go. 50. Cool. It's dropping. Yeah. So here we go. So just be cognizant of this. There's 3 rules you must know at this level, no? Will you get to use words one day? It's really up to your workplace, but I highly doubt it. People never tell you the secrets to the stuff. All right. So yeah, let's start here. I don't know why I did the chain rule first, but anyway. So this is product. Okay, so I think I have explained what product is about, right? Are we all familiar with the product? How to do it? Colleagues, can we all do the product?
Say again, sir?
Can we do the product rule? Do you know how to use it?
For me,
Yes.
yes, I'm okay with it.
Yes.
Okay.
I'm also okay with it.
You're all okay with this, right? And then you understand the quotient rule as well? Is that fine?
We can do one.
Does it do one? Not just
I
ask
think-
them. Yeah.
Yeah, we
Yes,
can
I'm,
do one.
I'm
Can
fine with
do
it.
one or two of the quotients.
Okay. So obviously, so I'll do one of these ones. Let me do what looks on do number 3 looks fun. And then okay, this is a cool one that proves an identity. Let me see. Let me just go to the exercise and see what we have here. Okay, let me just see over here. Okay. Okay, just come here. So let me do one. Just wanna get the rule for you, like just so I can make sure the rule's always next to you. Just pressing on that OneNote quickly. What I'm actually gonna do, I'm gonna take one from one of the papers, man. You know what I mean? So it's gonna be one of the papers you're working with now. Just give me a second. Okay. Can you guys see the quotient rule there now? I believe you guys can see it.
Yes, sir.
Okay.
Sure.
So let me do one of these papers here. Cool.
My
So, yeah.
screen is nothing.
Nothing. People say they can see it.
Nothing yet. Nothing.
Okay. Don't worry, it's coming now. Check now. Just checking
Nothing for
again.
me.
But just refresh on your side, maybe. I'm resharing again. I'm redoing it again. That's chain rules are one I really want to focus on. That's the one where people's always a bit lost. Okay, yeah, I got one. Perfect. Okay. Cool. Yeah, so this is the question. It's one of those papers. I think it's April or November. Then check the year. And here we got to do differentiate, and they tell you actually, with either the quotient rule, differentiate x with respect to y. The basic one dy dx. When you're looking at this over here, there are 2 notations you can use. One is the one of Newton, that's one of Leibniz, but they're exactly the same thing. I prefer the dy dx one. So for a quotient, if y equals u over v, and then the derivative of that, just applying a simple rule. We keep v, which is the second, find du dx minus u dv dx. Then we're just dividing that by the second one squared. So let's quickly apply it. So in this case, we have y equals tan x And that's ln x. And in this case, this will be u, and that will be
B.
b, right? Okay. So then, what you can do to dy dx, you can either find derivatives individually and then put it into the equation, or you can just go with the flow. So we know v is already ln x, right? The bottom part.
Excuse me, sir. I can't see anything yet.
Can everyone else see it? I think everyone else can see it. You must just refresh on your end. Maybe you must leave and come back.
I think it's basically leave and come back.
Yeah.
We'll wait for you.
Okay. Oh, that's v. So I can reach it quickly. Richard, are you back?
No, I'm still. I can hear you, but sir, but there's no. I can't see
No,
anything.
I'm not unsure again. Did you leave and come back?
No,
Leave
I was
it.
always here.
No, leave the Teams. You must leave it. Log out and log in again. You must go like log out and then come back in again. I still see you there, so I don't know why you're still here.
They did.
I left now, yeah. Oh, okay.
There we go.
Yeah, allow me. No one allowing you in. Okay.
I did.
No. Tanakaze, hi, I didn't see you. Sibulele, Kanisa, Heinrich. Okay, it's still loading. We're just getting Richard back. Don't know what's going on. It's taking a bit long. Just should
It's
have
taking
nothing.
very long.
He's in now.
Is he in?
Yeah. Richard, are you there?
I can hear you clearly.
Can you see?
I see nothing yet. Yeah, there we go. Thanks a lot,
Okay.
sir.
Right. So V is Linux. We found the derivative of 10. But now you should know that sec x, right?
Squid.
Yeah. You can actually prove it if you find dy dx of this sine over cos. Not sine over cos, cos over sine, which is essentially sec x. Sorry, sine over cos. You can actually prove that this is actually sec x if you find the derivative using the product rule. Maybe I should just do that for you. Then we have minus u is tan x. And then our derivative of ln x, by now I should know it's 1
over
over
x.
Yeah. And then v should be ln x squared. Okay, can't do much with that. Over here, looking at this, it's not much to do, but you'd say ln x, maybe I might say 1 over cos, right? Squared x minus tan, not tan, I'll make the sine over cos. You understand why now. Okay, that's going to be sine x, cos x times 1 over x. Now, so this one there's not a lot of simplification here, right? So you want to just actually check Then what I'll do on this one, on the numerator side, I'll take 1 over cos as a common factor. It's the only common factor I can see. And that's going to be ln x, 1 over cos x. Obviously, that's still there. Minus sine x divided by x. Okay. And I just divide all of this by ln x squared. You can go a bit further, but by taking this side and that side, it's put unnecessary. But that's basically it. There's nothing more than that. Yeah. The simplification part is more just looking for common factors, man. That's the key. So let me prove to you here that the derivative of sine x over cos x, which is
So
tan
can I
x.
ask a question?
Yes, you can.
After we did apply the rule, which is
Yes.
ln x times sec x squared, if we leave it at that part, is it still fine, or must we go into what you did now?
So typically they might give a mark for each. What I've seen, like they give a mark here and a mark here. You understand? Or maybe a mark for the bottom, but they give a further mark for the it depends on the amount of marks for the question. In this case, it's 3 marks. Can you see? So it's easy. So maybe if it's 5, they're expecting a bit of more, simplification.
So we need to check the marks to see how far we must go.
Yeah. That's what I would recommend. The moderator might
a
even,
rule of thumb
Yeah.
is
yes?
I understand a rule of thumb is almost like to the simplest as you can.
Yeah. That's correct.
Is that true?
That is true. That's true.
Okay. And is
Yeah.
it true? And somebody told me that try to get a radical out of the denominator.
Yeah.
And also the negatives, those kind of
Yeah, raise it.
things.
Yeah. But it's not overly critical, man. You know what I mean? Like, don't put your head too much on it, man. Because I mean, you have a whole paper to tackle. Remember, an exam is not there to measure intelligence. It's just an
Okay.
exam. Yeah, just if you have that space to do it, then just do it. Because you have a lot of other problems to tackle. But it's like I said, the rule of thumb is definitely correct. Sometimes we must choose our battles. You know what I mean? So like this case, I'm gonna show you.
Okay.
Yeah. Tan x, and we're gonna see if it's true that its derivative is actually sec x squared. So v is cos derivative of what is this one now? Of the second, the second one is going to be cos as well, right? Then we say minus u is sine x. Derivative of the one in the bottom, that's derivative of cos, it should be negative sine, am I right? Is that correct? Let me divide that by cos. Why am I saying cos squared here? This is the cos, no? Yeah. Then we say cos times cos is cos squared x. Negative is a plus, am I right? You guys agree with me?
Yes.
Over cos. What is cos squared plus sine squared is 1. What's 1 over cos? Sorry, this is supposed to be squared, no? Whenever it's v squared, am I right?
Yes.
Yeah.
Yes.
And then 1 over cos squared is going to be sec squared.
Secant squared.
Yeah, exactly. Secant squared. And of course, we've established that is. Yeah. What you tend to find with engineering science, the engineering domain, we don't do a lot of proofs. It's more of applying stuff, but sometimes these proofs come out to you. Yeah, and the intuition sometimes is important to understand where things come from. So let me see here. Maybe I can give you maybe one to do, then we can do chain rule. Let me just find one quickly. I'm going to the book. I'm gonna just choose a random. Yeah, I want to choose a random one. Okay, try this one. Where is it now? Okay. On the screen. Then we're going to end off with chain rule. So try this one. There you go. And again, guys, ask the questions, right? Here we go. Find the derivative. Find dy dx. I believe you guys know your integrals, I mean your differentiation by now. Let me be kind and put the table for you. can see the, what's this? The derivatives. All right, let me give you 3 minutes for this. Right. Right, there you go. I believe that should assist you. Okay. Yeah. And if you're wondering which one is this one, it's going to be this one over here. No? This one over here. And obviously K in this case is 1. Just by the way, there's no number in front of it. Just letting you know. Right. All the best.
I think I'm finished, sir.
You think Loris said is done? Or was it?
Say again.
Oh, who's done? Richard. Oh, Richard, sorry. Oh, okay.
Yeah, I said I'm finished, sir.
Anyone else? Kanisa? Luvuyo? Sibulele? Are you guys deaf or are you silent?
We can hear you, sir. I'm still working on it, sir.
Oh, good, man, good. So, let's say 2 more minutes left. No, we don't have to take too long. All right, colleagues, are we winning? Can we move?
Yeah, you can go through, sir. We'll see.
Okay.
Sir, can you can I maybe take you through it so that you can see
Okay.
whether my reasoning is right or not?
100%. So dy dx equals, talk to me.
Okay, so what I have then is cosecant x
Yeah.
times 4 to the power of x, natural log of 4,
Yeah.
minus 4 to the power of x,
Okay.
times negative cosecant plus cotangent x.
Okay. Yep.
over cosecant squared.
Just give me a
That is the
second.
answer. So
Yeah.
then, and if I simplify it, obviously the top I can take a cosecant x out, and I left
Just give me a
with
second. Yeah. Yes, you're right. I'm doing exactly the same thing. Yes.
cosecant x, and then times, then it's 4 to the power of x, natural log of 4,
That's a lot
Plus-
of 4. Yes.
plus
But don't
because there's
Don't you
a-
think we can? Don't you? Just very quickly. Don't you think we can take
4 to the
another
power of
common
x.
factor of 4 to the power x?
4 to the power x, yes.
Yeah.
You see that, Richard?
Okay.
Yeah. Can you see it?
Yes, I see that.
Yeah, that's ln 4 now only, plus or rather negative cot now. You see there? Cot x.
Okay.
You see? That's common because that's together. And that's
They-
together.
On top, sir, that plus minus shouldn't be, must be negative.
This one, which one?
The top plus.
This one-
The sign
that one
before
is.
4 to the power of x.
It's negative,
That
no?
That must be negative,
Negative.
and then the bottom one is positive then.
Okay. So is this positive here? Like that? Yeah.
Yeah, yes.
Okay,
yes,
perfect.
yes.
Okay.
Over
obviously-
cosecant square,
Yes.
and then I just did another step where that one cosecant goes up with the other one,
Exactly. Yeah.
and then it's, yeah, that is what I,
Yeah. Now then you're right here.
No, but sir,
Yes.
it's ln 4 minus cot x,
Minus
not
cot
plus.
The minus
wait.
stays there, so.
The minus.
The
Yeah.
minus stays there. That one on top where you were now, that comes a plus.
Okay, let me just quickly see. It's fine.
the,
But so
the-
yeah,
the-
yeah.
No,
it's-
no.
So this is negative and that's negative, right? So this becomes positive. All of this.
yeah, that's a multiplication. That's 4 to the power
Yeah.
of x times negative cosecant cotangent x, and that
Yeah.
makes it
And
a
then I
positive.
did something wrong because I got
Yeah, I agree with that. Yeah, that's correct. And then this should be over cosec.
okay.
So to say,
Okay.
if you
It's
didn't,
Yes.
so if you didn't, you only took out cosec x and then you leave the other stuff. On the next
So-
step,
So
you can
I'm not.
still,
I'm not sure how the sessions deal with it, man. Like with at the TVET colleges. I mean, at another institution, there is that grace of the system to say, okay, you've understood the concept. But if they're marking strictly towards the memo, which I believe they might be doing, it might cause you to do some marks. They might even do the, like this, like a half mark. You know what I'm gonna say to you. So there is that possibility. If I can show, I'm gonna just find this thing here. So I'm not marked final papers, man. So I don't want to say, you know what I mean, the approaches. But I have a guideline on what's what I'm looking for, on what possible marks could, like marking style could look like. I just don't know where it unfortunately is. So I got it on my phone somewhere sometime. But anyway, yeah. So they might give you half a mark instead. You know what I mean? Yeah. Okay. So I believe we're all happy with this. No? Easy.
So
But can we
yeah,
go
so that-
further?
No, that's enough. That's
No,
enough.
that is the answer, yes.
Yeah.
That
What
first
to be
step is
clear when
actually
you
the
wanted to can
answer.
go forward.
Yeah, you can, like, you don't, that's what I'm trying to say to you. You have to look at the marks because now you're going to spend so much time. Like, you can do this. Let me show you. Learn 4. Cosec. You understand? Check this. Are you with me? I can do this, right? And then on this side, I leave it. But this
Yeah.
is what? This is cos over sine. This is not going to impress anyone, by the way. I'm just letting you know. And then obviously this can be flipped 10 times. This will be cos over sine squared. You know what I mean? You can do that, but it's necessary? No. I want to see how you apply the product rule with some slight, you know what I mean? Slight fact, simplification or common factor, whatever. Yeah. Concept is finding the derivative. Is that fine for everyone?
Yeah, but just one question.
Yes.
Isn't that 4 to the power x ln 4 plus cot x?
Let me just quickly see. I'm just getting something else in the meanwhile. Maths. What's it? Okay, just give me a second. Okay. Got what I want to do. Yes, sorry. You're
There
saying?
where we are now, no, go there by 4x ln x in brackets over cosec x. Isn't that 1 over cosec x then equal to sine x?
This what? This one. What you saying? This one at the bottom.
If you
That-
take
This cosec, right? 1 over sine x. Yes.
mm,
Yeah, then you can flip him and it'll become sine x here. You know what I'm saying to you? But you don't need to be too, like, you know what I'm saying? This is 1 over sine. You know what I'm saying to you? And you flip him over.
and it
And
becomes
yeah, don't worry too much about, it's not gonna save you in the exam. You just get at least the amount of steps. I mean, a question like that, okay, there's no marks attached to this one. Okay, is there any other questions with this? Okay, assume there's none, eh?
For me, I'm okay now, sir.
Okay, so now I'm gonna just drop one in front of your face. And I expect you guys to do something. I'm gonna see if you guys are able to do it. This is my plan. This one. Then it's 3 marks this year. Okay. If you don't know how to do it, it's fine. I'm gonna go over. I'm just gonna see if you're able to do it. Okay. There you go. Do this one. Find the derivative. Yeah. That's objective.
Yeah.
Okay. You guys got it? Obviously, I believe you guys know what it is. But
Yes.
okay, let's see.
I got the answer of 1 over the square root of cosine.
What's again?
I said I got the answer of 1 over square root of cosine.
It looks suspicious to me. Yeah. Anyone else? We can put the answers there. Hi, Dylan.
isn't 1 over square root of
That's not the answer, eh? That's not the answer was given there. I just asked what are your answers. You can tell me your answer.
no, it's fine.
What is your answer?
1 over square root cos x.
Say again?
1 over square root cos x.
Same answer. Yes.
Yes.
Very worried.
It's 1 over 2
Okay.
root
1
cos
over 2.
x.
Could yes, 1 over 2 cos x, yes.
Yes.
Okay. It's looking a
Yes.
bit better. Yeah. Is there any more people who try?
The bravest I can be.
Kanisa, London. All right. Can I come in?
Please.
All right. So I'm going to do this one, and I want to start to go back and explain what's going on. So the keys, you understand that there's a function of a function was the chain rule. dy dx is going to be equal to du dx times dy du. Now, I don't know if this is correct because this one, this u, and this u must be dy dx on both sides. So that is very important to remember. So when you do this, you want to establish a u. And typically a u is the argument of whatever you see. Something inside a bracket or something of. So we have a sine x, but it's subjected to a square root. So the argument would be the one on the inside, which is the sine. I'll explain to you what that's all about. So we say y equals root of u, and we declared u as sine. Okay, so the main game here, right, is to populate what that is and times it by that derivative. So in our first case, why am I doing that? Let's come to the u. So we know that du, dx, right? Those are two variables. That's going to be cos x, am I right? Then we must find the derivative of this guy. You know, that's y equals u to the power of, is it not so? So we must add one, am I right? We add one. The dy dx is going to be, you times a half like this, right? And you say but you subtract one, sorry. So it's negative, am I right? Like that? Which is essentially 1 over 2. You can have a u to the power negative half. I'm just being very deliberate. Then you can obviously carry him over and say 2 over root u like that. Once you have this, we have dy du. Forgive me for this one. Again, independent variable. Yeah. So dy du comes over here, which is 1 over 2 root u. And then we have du dx, which is cos x. You can see that there, right? That's what everyone must, it seems. And then you must then you can say cos x divided by 2 over u, but u is declared as sine. There you go. That's function of a function. Do you guys follow that?
How?
Huh? Talk. Any questions? I'll explain. Don't
How
worry.
come everybody got the 1 over 2 something? What did we
Feels
do?
like we didn't finish.
Yeah, it's right. You're definitely right, but this is what the function of a function is. And so I thought maybe you guys thought you knew what you're doing, what you guys I guess didn't. Are you guys familiar with this?
No.
Yeah.
Clearly not.
Okay, right. So let me do this. So what I'm going to do now, I'm going to share the book, and then I'm going to show you exactly what's happening here. And you remember now. Okay. So again, yeah, you'll see. When I could do this is when I became good at maths. Nevertheless. So here we have again the chain rule. Chain rule is used for differentiating a function of another function. So function of a function, same thing, composite function. And it states that if u is a function of u and the u is a function of x, then dy dx is equal to dy du times du over dx. I hope that's clear to everyone. Right? That's the chain rule by definition. And then this is how we can apply the chain rule over here. But before we talk about applying the chain rule, I want to open your mind to what is a function of a function. Okay. So you can identify what it is. So let me just come here quickly. I'm going to read this note to you, and then I want you to apply what you've limits. Okay. Yeah. So let me explain to you what an argument is. Don't have to know the word argument, but it says the argument of function, the quantity of the function operates on. To illustrate, can we see that we have sine 3x there? Are we all happy with this? Can we see it? Colleagues?
Where are we now?
Where
Where's
are
the
we, sir?
question paper, sir?
We're in a question paper.
Yes.
Which question?
Don't worry.
Okay.
I thought I was on the book. I thought I was on the book.
No.
No, I wasn't. Let me share my screen, man. Let me share screen. Okay. Can you see now? Yeah. See this? Right? Can we see this? The book.
Yes.
Yes, sir.
Yeah, it's old notes. Yeah. All the old notes are the best ones. So in sine, can you see sine 3x over here, right? Yeah. So the argument of the sine function is 3x. Does it make sense to everyone? Inside, you have sine x, but inside that sine x is a 3x. That is the argument, because 3x will affect the sign. Is it clear to everyone? In this case, we have a root of ln x, right? And inside the root sign, which is a function, there's a ln x. Therefore, ln x will be the function. We have ln root of x, as ln x. And inside the ln x, this bracket here is a root x, and that affects the ln. Therefore, that's the argument, the root x. And we have e tan. Obviously, normally it's e to the power x, and that x over there is tan in this case, so therefore tan is an argument function of the exponential function. Is that clear to everyone? That's a function inside a function. Are you guys happy with this?
Yes, sir.
Do you understand what that means? So if I look at this over here, right? Sine 3x minus 4. What is my argument? Looking at this, tell me.
3x minus 4.
Exactly,
minus
what's in the
4.
bracket. Yeah, this is what's key. If I look at e cos x, what is my argument over here?
Cos.
Cos x.
Cos x.
Cos x. Okay, so I'm happy we're getting the idea of that. Now, here's my info book now. Let me illustrate the function of a function. And this is the procedure. I'm gonna do something more. Something like, I know what I'm looking for. Okay, let's try. Okay. Let's see here. Yeah.
Number 5.
Yeah, not number 5. We'll do number 1, or do number 5 again. Number 5 is, yeah, let's start to number 5. Either or, it's okay. Come back to number 1 again. Okay, let's do number 5. Yeah. Right. Base team. Right. Function of a function. Right. And normally, luckily for you guys, I'll tell you when to use it. So the chain rule is, and I was going to be kind, so I can put it for you. Yeah, go to your exam paper and I'll put it there for you, so you can exactly see what this is about. So remember this. There's it. Then I'm going to paste it here for you. Okay. So the job is this. This is the job. All right. So what is my argument?
Sin x.
Sin
Yeah,
x.
sin x. So that wherever your argument is, that's going to be your u. U equals sin x. Are we all happy with this? Right?
Hmm.
Now let's find the derivative. Du dx. What is the derivative of that? Cos x, right? Exactly. What's the derivative of e to the power u? Dy du. What is it? Doesn't change. Exactly. Then we say dy dx, and we come to this formula now. That's going to be dy du times du dx. And then dy du was e to the power u. Du dx was cos. However, we declared sine as what? U. So therefore, e sine x times cos x. There you go. Is that clear to everyone? You understand how it works now? But let me not go there yet. So any questions? I feel like I messed your brain up or something.
It did.
No, it's okay. Can I just ask one question quickly?
Yes, for sure.
For me, it's okay with it. That cosine
Yes.
x,
Mm.
must, if you leave it like that, will it be fine? Or if you write in front of the ex, is it the same? Is it obviously the
Same thing. Same thing. Yeah, doesn't matter which one.
But what if now if that cosine was a negative?
Negative cos x e sine x. Done.
Yes.
Done. Finish. Nothing
Okay.
more, nothing less.
Okay.
So let's do another one. I guess the experience of teaching math has helped. See,
Are you only teaching this level, or are you doing extra
I'm
as well?
teaching strengths N5 also, but I've taught a lot, man.
But I mean, higher math like
Yeah, I have,
math 3 and stuff.
Yeah. I started my teaching career teaching math 3. In math 3, yeah. Yeah. So you know, yeah, anyway, let me not say anything. Okay. Dy dx is equal to what's it again? Dy du, right? And then we have du dx. I always know this is right because that du's must cancel, so we have dy dx. Hope everyone understands. Okay, so what is my argument here?
Sec x.
Exactly. So that's going to be u. Therefore, our argument we declare as u sec x. You see that? Are we happy with this? Let me say dy du. Are we happy? 1 over u. Du dx. What's the derivative of sec x again?
Sec x
Sec
tan x.
Cos.
tan x. What?
Secant
Sec
tens
x
and
tan x.
Tan x.
yeah.
Yeah, sec x tan x. There is another way of writing it. Where's my derivatives here? Yeah. Sec x tan x. Sometimes it's not the devil, sometimes you are own enemy. Sec x tan x, right? Is that cool? And again, we're just multiplying this. So what is my du dy with du? It's 1 over u. And we multiply the second one, which is sec x tan x. And then 1 over u is, obviously we declare what u was, that's sec. Therefore, that's 1 over sec x. Now we have sec x times tan x over 1. Obviously, we can easily just say goodbye and goodbye, am I right? And therefore, answer is going to be tan x.
Tan x.
That's correct. 100% correct. You guys know what the integral of tan is? It learns it.
Ln sec x.
Yeah. Can you see that? This mass can increase your blood pressure, no? Just letting you know. Be cautious. See there? And if you integrate backwards, you should get ln sec, right? Is it not so? Yeah, there you go. I feel like I tell you guys brain damage is like you're like what? I've been doing this thing wrong my whole life, and now I'm realizing that this is what it is. This is
2
what I
days
feel.
before the
It's probably
exam.
too late now already.
It's not
Really?
late, but it's straightforward, right? Is it not straightforward, guys? Do you feel like you did I really mess you up, or can you imagine? Can you, okay, I'm gonna give you this one in the paper here. No? 4.3. Do this for me. You know what I love about these times? I wish I wonder who was a colleague who was teaching people the chain rule wrongly. They were so confident with your answer. But anyway, I love seeing people do that. Can we try this one? And they're so sure. No, it must be like this. It's like, oh man. Okay, try this one. It's from a paper as well.
What is it? Is it cosine what?
Cosec doctor. Cosec doctor.
A cosec. Okay.
It's not too late. It's not too late. It's just in time. In 4 August. Okay. I mean, the procedure is fairly easy to follow, I believe. I highly doubt that I have any intellect. It's just a matter of practice.
With intuition.
Yeah, yeah. It's the textbook is fairly straightforward. It helps you quite nicely on how to do it. Yeah. Are you guys winning?
I've got the answer.
Okay, let me do it. Y equals root of u. You know, I'm going straight in. U equals cosec. What's my derivative of cosec again? So I really don't know. Du over dx.
It's
Not
negative.
cosec.
Negative cosec.
Negative cosec cot x.
Cot.
Okay. Cot. This guy will be dy du, which is 1 over 2 root u. Am I right?
Yes.
Yeah, therefore dy dx, we multiply both of them, 1 over 2 root u times minus cosec x times cot x divided by 1. Multiply everything in, we have a minus cosec x cot divided by 2. What is my root again? Cosec.
Secant.
Now, if you really want to be cute, this is to a power half, that's to the power 1, am I right? Are you with me?
Mhm.
Then this will be cosec on the cosec x on top, am I right? Cot divided by 2, and then you're done. If you're unsure what I mean, what I mean by that, remember a root's power is what? It's a half, man. Draw a line for you, here. You raise this guy like a half. Are you with me? So 1 minus half. You see what I'm saying? Yeah. But I'll just give you marks probably for all of this here. You guys get that answer?
Yes, sir.
There you go. Just before the exam. You guys remember me now when you're doing the chain rule. So let me just quickly show you. Yeah, let me show you here. Can you see here? There's that one. You see there? There. Let's end off with number 7, eh? Is that fine? Okay.
Yes.
Yeah, I'll let you guys try first, and then I'll come in afterwards. Let me unshare. Right, this guy can make another section with paste him here. So I like this one. So can someone tell me what is my u?
And 4x.
No, it's
4x.
it's cos.
Cos
4.
4.
What is it? What is my u? Can I write this another way for you?
Yes, sir.
So what is u?
Cos x.
Cos X.
Exactly. Yeah, u is
Hmm.
cos x. So therefore y equals u to the power 4. Am I right? Carry on. When you're done, just say so.
Yes, sir.
Okay. Anyone else? Are we still busy? What's du dx? Negative sign, right? No. Yeah. Negative sign, right?
Yeah.
That's fine. And then dy du is, what is it? 4u.
4u to the power 3.
Exactly. Therefore dy dx will be 4 U cubed times negative sine x. What was my U again? My U was cos A. Am I right? Was cubed x negative sine x. And then you're done. Just in time.
Hmm.
Any questions, guys? We're at the end here. Shona and Isipo, welcome, guys.
Yes, sir.
Any questions? Any questions, guys? You guys got it?
No, sir.
Okay. All right, guys. Any questions before we close?
From my
I
side,
think
sir,
the
nothing.
integration.
Sorry?
Yes, I have
Someone-
a question, but it's not on the
What is it on?
topics.
What is it on, Chief?
So, sir, how long have you been in the industry?
Why?
No, you can stop the recording, sir. I want to ask something.
Okay, okay. Let me stop. Let me stop. So I believe I'll conclude here. No? Okay.
Yes,
Yeah.
for now.
Yes. For now, no.
Yeah.
All right. Yes. Yes. I'm here. It's done.